Hello children, I hope you have seen your first part video of this lesson Unit 2 Mechanics. So with that previous knowledge, now let us move into part 2 of this lesson, this unit Mechanics. Before getting into the concepts which we are going to learn here, you have to recall some concepts. So they are: what is motion, what is rest, what are scalar quantities, and what are vector quantities. Now, this you have learned, right? In your 6th standard or even in your first part of your video, you would have seen it. When any body moves from one point to another point with respect to time, then it is said to be in motion. Right? Now I had moved from there to here in a quite interval of time, maybe 2 seconds or 3 seconds. So I was said to be in motion. Now I am standing here even when the time has been passing out. Right? So now I am at rest. Right? Now this motion means movement with time. Rest means no movement of any body with time. Right? Now then the next quantity is, there are some quantities which will be called as scalar quantities and vector quantities. Right, I'll tell you one example. That if I take this room temperature, right, it may be around 30 degrees Celsius. Let us take for that as an example. Can we say in this direction it will be 31, in this direction it will be 32, in upward direction it will be 29? We cannot say like that. No. Room temperature means in that particular room or in that particular surrounding, it is 30 degrees Celsius. So depending upon the direction, it won't change. So you would have learned some quantities also in previous classes, 7 fundamental quantities and some direct quantities. That quantities, if they have the numerical value alone, so that's what I have given here. Right? A simple example I can give you, right? If I count the number of students in one particular class, right? Example 40 or 30, right? The 30 or 40 I am saying, no, I am assigning one number for one particular quantity. Or else, what is your body temperature? What is that? Normal body temperature we would say, right? So that number we are giving, 97 degree Fahrenheit, like that we are giving. So that number is called as magnitude. For some quantities we can give number alone, magnitude alone. We cannot specify the direction. Such quantities are called as scalar quantities. For some other quantities we are going to see in this lesson. We can give both magnitude, number also we can give, direction also we can specify. So such type of quantities are called vector quantities. Remember, scalar means magnitude only. Vector quantities means both magnitude and direction. So these are the key points. Have your pencil in your hand. Take that motion in straight line lesson in your textbook, which is around pages 25. Right? So motion in straight line. Page number 18. Okay, from there we are starting. So then under these recalling points you should underline in the subsequent pages. Right. Now in this lesson we are going to learn these concepts: distance, speed, displacement, velocity and acceleration. Why am I giving in these different colors in 2 columns? There are numerous stories to be learned here. Stories we don't expect once upon a time and all. The realistic stories. So distance, first we have to learn the definitions, then what are the interrelation between these two, why this is grouped here and why this is grouped here, why this is written in the center. So all those we are going to learn. Distance. For example, take this scale, right? From this edge to this edge, what is the length in between? So the distance between 2 points, that is the length between the 2 points, is called as distance. This is a simple example. If you travel from your house to your friend's house, so the length you cover is called as distance. So the distance is a type of length. So is measured in meter. So distance unit is meter. So whenever you are learning these quantities, compulsorily you have to learn that particular quantities units. So remember all those record in your mind. Okay. Any quantity when you learn it with its unit. So distance unit is meter. Right. Now speed. For speed I have one formula here. Speed is equal to distance by time. So in physics generally children, every concept, every quantity we will compare with time. Right? When we compare any quantity with time, we call it with one keyword called rate. Say the word rate. R-A-T-E. Right? So now this any quantity when we divide it with the time, we refer to it as rate. Rate of what? Now you see here. Divided by time is rate. Rate of whatever is there in the numerator. Now you say the definition for speed. Rate of divided by time means rate. Rate of distance is called as speed. Otherwise, we come in that way. Speed is the rate of change of distance. Clear, children? When you cover a distance, right? That distance, when you divide it by the time what you take, then that is called your speed. Understood? Right. Now, definition learned, formula learned. What is definition? Rate of change of distance is called speed. Then unit we are going to learn by this formula. What is the formula? Speed is equal to distance by time. See children, when you know this formula, you can relate other concepts without memorizing. Right? So no need to memorize any concepts from your lessons or textbooks. Understand and learn. Understand the formula. Speed is equal to distance by time. From this formula you can get the definition. Now I will teach you how you are going to get the unit also. Right? Now what is distance unit? Now only I said when I was explaining here. Meter. So meter will come. What is times unit? Don't blink children. What is times unit? Second. So that second unit is in the denominator. Yes, no. So that denominator, yes, will have power 1. If you don't have any power, it is understood as 1. So that is in the denominator. When it goes up to the numerator, it will go as -1. So any denominator quantity, when you take it to the numerator, you should go with minus sign. So that is what you have. Meter, yes, second, power -1. You will have a confusion how to read this. So many children will easily read this. ms power -1. Yes, of course it may be correct, but it is not appropriate. How you can write like ms power -1, but when you are reading it, you should read it as meter per second. How? Meter per second. Read it and practice. Right? So you can write in short forms, but when you are saying it, say it in full form. For now, as an example, if there is 2 here, how you will pronounce it? Meter minus first. Per. Minus how will you pronounce? Don't say minus. Per. P-E-R. Per second. If it is 2 here, square. Right? If it is 3, meter per second to the power of 3 or meter per second cube. 4 means meter per second to the power of 4. Like that only you have to do. Okay. Now what is the unit of speed? Meter per second. How that came? Distance unit is meter. Time unit is second. As it is in the denominator, it will go to the numerator with minus power. So can you understand this? Now the same concept come over here. Displacement and velocity. Whatever you have learned here, that will come here. But I will tell you an example. One small difference is there. Right? Now, when I want to travel from here to here, right? Now, how I can travel? I had at least 3 steps only to start from here 1, 2, 3, right? Now, this distance I can cover it in any method. What I can do, straightly I can come like this, or I can go to my right and come back here, or I can go to my left and come here, and I can take a round in the class and I can come back here, or even I can go down or go to the other place and come back here. But what is the starting point? I start here. Where is my ending point? Here. This is whatever may be the mode of travel. What may be the how I travel, where I travel. The length between the starting point and the ending point is called distance. But among all these distances, which will be the shortest? Starting from here, having 3 steps here. So that shortest distance is called displacement. That symbol is small s. Okay, small s. Velocity symbol is v. Distance symbol is d, they will say sometimes. L they will denote. And speed symbol is s. Right. Now this displacement symbol is small s. So what is displacement now? The shortest distance is called as displacement. Now you say, whatever direction you travel, that is called distance. So distances are not direction specific, but what about displacement? The shortest distance. So it becomes direction oriented. Displacement is direction oriented. Now you come to the recall concepts. What we said here, scalar and vector. What I said, scalars will have magnitude alone. Vectors will have both magnitude and direction. Here in these two, this will have the value alone. Whatever may be the length, what is the measurement of the length you cover is called as distance. So it is called as scalar quantity. But among all the distances, the shortest distance, the direction oriented, that is called displacement, which is a vector quantity. That's why I written in 2 different columns. So these 2 are scalars and these 2 are vectors. Right? So remember this. Now displacement, you know, it is also the shortest distance. Of course it is also a distance, but it is the shortest distance. Now you come to the next one, velocity. I have a formula here. Velocity is displacement by time. Formula, now give me the definition. Divided by time. Divided by time means the rate you should use. So what is the definition? Rate of change of displacement is called as velocity. Or velocity is the rate of change of displacement. What is its unit? Displacement unit is meter because it is a distance. And time's unit is second. As it is coming in the denominator, it will have power 1, and when it comes up, -1. So ultimately, what is the unit of velocity? Meter per second. Now, in between these two, we have a common factor called acceleration. Say the word acceleration. Some children will say acceleration, acceleration. No, pronounce it correctly. Acceleration. Right? Now, why I written the center is, in this level at the 7th standard, rate of speed is also acceleration, rate of velocity is also acceleration. Now, when you go to your higher classes, you have some advanced concepts in it. So that you learn it later. Now, as of now, acceleration is more confined to velocity. Right? So that's why as it is a common factor for both speed and velocity, but more confined to velocity. So that's why I have written it in center. So what is the formula for acceleration? Acceleration is equal to velocity by time. So this is your formula. What is the definition now? Come on, start. Divided by time. Divided by time means rate. Rate of, what is there in the numerator? Velocity. Rate of change of velocity is called acceleration. Otherwise, how you can say? Come from that side. Acceleration is the rate of change of velocity. Clear? Now come to the unit. Here only you will get confused. Here already we have derived velocity's unit is meter per second. Here velocity is there. What is its unit? Meter per second. Another time we have meter per second by second. So meter per second is there. Already time is there. That will have s power 1. Then it goes up s power minus 1. So meter s power minus 1, s power minus 1. So minus 1 plus minus 1 you will get minus 2. Right? So that's why acceleration's unit is meter per second square. Clear, children? Now you have some graphs over here. By seeing the graph itself you can say what type of motion it is. Right? Now see here. This is on y-axis I have taken velocity, x-axis I have taken time. That means simple children don't get confused. Think that we are going in a bike with one particular speed. Don't go and you take your bike and go. Don't think like that. Imagine that a person is traveling in a bike. Right? Now you see here you are going with one particular speed alone. In first second you are going in 40. Second also you are going in 40 km/h. Third minute also, minute of second, you are going in 40 km/h. So when you are traveling in one particular speed, or if you are not moving at all, so that type of movement will give you this graph. So that type of motion we can say uniform motion graph or rest graph. The definition I am going to still explain you here. First learn the graph, right? So this graph, by seeing the graph like this on a horizontal line, you will say it as uniform motion graph at a movement of a vehicle which is at rest. Now you see this. Now for first time, first minute or second or hour, the velocity will be here, right? Like this. Velocity will be here. For next time, it will be here. If it is increased here. Like that, as time increases, velocity is also increasing. So that is what this line says. So this type of graph is called as graph for non-uniform motion. Okay, right, now you come here. There is another graph I have given here, velocity and time. Now, first I am saying here, this velocity is increasing with time. Velocity with time is called as compared means that is called acceleration. Now you see here, now when I am increasing my bike speed, so graph is this. Positive acceleration, increasing acceleration. Now this graph shows that it is at steady state. Steady state means two meaning. One, either the body is at rest or it is at the same speed. For example, if the vehicle is traveling with 40 km/h for quite particular time, or if the body is taking rest, then the graph will be denoted by like this. Then if I decrease my speed in my travel, then graph will shoot down. That is called as negative acceleration. It is denoted by one another word called as deceleration. Say the word deceleration. D-E-C-E-L-E-R-A-T-I-O-N. These details I will give you in the notes, children. Don't worry. Okay. So deceleration. Deceleration is otherwise called as negative acceleration. And from here, if it is randomly increasing, straight line means regularly increasing, randomly increasing, shooting out means randomly the speed is increased. So it is also positive acceleration. So this is a mixed graph of increasing acceleration and or decreasing acceleration. Okay. So now why I have said this graph is seeing the graph you should say what type of motion is this. So for that only I have selected this graph, right? Now we have one definition to learn at the last, right? Now we have the definition called uniform motion. What is uniform motion? If a body covers equal distances in equal intervals of time, it is said to be in uniform motion. Right. Have you seen your pendulum clocks in olden days? Pendulum clocks. Right. So the pendulum clocks in the center it will be one bell-like structure. Right. Now it will hang like this for 1 second. It will go to that side, and it will come back to this point in 1 second. Or else you can count like this from the center. Right. It will go to that side and come to the center. That is 1 second. Easily you can remember like this. From starting point, this point is the starting point, going to the other side and coming back to the other same point. So that is 1 second. That means what? In 1 second, that pendulum is moving from one point and coming back to the other point. So that time taken is 1 second. For every 1 second, it will travel that particular distance only. Like this, if any body travels the same distances in same intervals of time. For example, another example, if I travel in the car, for 2 minutes if I go 1 kilometer, for every 2 minutes if I cover 1 kilometer, then I will be said to be in uniform motion. Take our rotation and revolution of the earth. For 24 hours, one complete rotation. For 1 year, one complete revolution. So this type of motion which is covering equal distances in equal intervals of time, then the body is said to be in uniform motion. With this we have some other concept with acceleration due to gravity, children, that we will continue. Children, when I was explaining you about the speed and velocity, one concept needs to be told, that is average speed and instantaneous speed. And what this can be applied to the other terms also, which is velocity and acceleration. That is, whatever it is, speed, velocity or acceleration, you call it with two words. Average speed, average velocity, average acceleration. Instantaneous speed, instantaneous velocity or intensity acceleration. Right. There are two words, average, instantaneous. I will tell you one example, right? When you are going to your relative's house. You start from the house, right? Taking your cycle. Or by walk, whatever it is your wish. Right? Now when you are going, you will go with one particular speed. Right? On that particular speed, suddenly on the road if you meet your friend, you will suddenly reduce your speed, come to rest, you will talk to him, some time will be consumed, and then you have to go faster to your relative's house. Now what you will do? You will increase your speed, and then you will drive fastly and go. This is a very simple example I can say. Right? Now you are going with one particular speed, yes you will keep it. Then you are coming to rest when you see your friend on the road. So that is, speed is 0 or velocity is 0. Now then you are increasing your speed to compensate the time. Let us keep that to be 1. Right? Now come to these two words. Average speed, average velocity, average acceleration. What is average speed? Now first you were traveling with one speed x. Now then you are at rest, that is 0. Then you travel with another speed y. So totally, what is the speed you travel? Right? So total speed by time, total time. If you have reached your relative's house in 20 minutes. So what is the total speed by time? That means what? X plus 0 plus y by what is the total time taken when you start from your house. Then reach at your house. That is your average speed. That speed is same as velocity, because speed is also distance by time, velocity is also distance by time, but what distance? Shortest distance, which is called as displacement. Then that particular average speed or average velocity, when you again divide it with time, you will get it as average acceleration or average acceleration. Now come to the next term, which is called as instantaneous speed. Instantaneous velocity. Instantaneous. That means what? When you are at one particular instant, what is your speed or what is your velocity? When you are traveling from your house till you meet your friend, what is at particular 20 minutes you took? At 15th minute, what is your speed? At 4th minute, what is your speed? What is your velocity? What is your acceleration? When we say one particular instant, what is your speed? At one instant you had come to rest also. So at that particular point, what is your speed? 0. So when you say confined to one particular time at one particular instant, that is called as instantaneous speed or instantaneous velocity or instantaneous acceleration. Children, I am here combining 3 concepts in one single explanation. So you have to expand your understanding and learn it. Right? So in simple, children, average means total by time. Instant means at one particular time. Whether it is speed or velocity or acceleration. Clear, children? Now the next concept is acceleration due to gravity. See a beautiful word. No, yes, it is acceleration due to gravity. Acceleration I have explained you already. Rate of change of velocity or speed. If that acceleration happens to be due to gravitational force. What is gravitational force? It is the force given by the earth. Any body will be attracted towards the earth with a force which is called as gravitational force. If any body is accelerated means what? Either its speed can be increased or decreased, which is due to gravitational force. That particular concept is called as acceleration due to gravity. Okay, this acceleration due to gravity will be varying from one planet to another planet. For Earth, it is denoted by a small letter called G, which have the value 9.8 magnitude. What is the unit? Meter per second square. Just now we learned unit of acceleration is meter per second square. Clear? So now come to the definition. Acceleration due to gravity is the rate of increase in velocity of a freely falling body due to gravity. This is one specific definition, children. See here, when a body is falling, right, what is its change in velocity? Generally, when a body is falling, its velocity will increase. In another case, if a body is moving up, its velocity will decrease. So here the consideration is falling body, which is coming down. So its velocity will increase. So what is the rate of increase in velocity when a body is falling down? That is due to the gravitational force. That is called acceleration. The simple way can I say you in understandable way? What is acceleration? It is the rate of change of velocity. If that acceleration happens due to gravitational force, then it is called as acceleration due to gravity. Acceleration created on a body due to gravitational force is called as acceleration due to gravity. What is its symbol? G. What is its value for Earth? 9.8 meter per second square. In your book, it will some other planets values also are given. Go through it, right? No need to memorize all the values now, right? You won't be asked for, but this value is important. But for Moon, it will be around 1 point some decimal values will be there, right? But when we compare these two values, gravitational value on Earth and on the Moon, it will be 1/6 lesser on the Moon, right? So that comparative value you have to know. Now come, we have a very important concept which are called as equations of motion, right? So don't even map has scattered something on the road, right? Very important concept. Newton, Sir Isaac Newton, you know, he had given 3 sets of equations. which will describe a substance in motion. Okay, he said some values, and this equation he had derived it. Right? So you now, as of now, you need not to worry about the derivation, how this equation has been derived by him, which you will learn in your higher classes. But that result you are going to learn now. I will read it and explain it. First listen. B is equal to U plus AT. S is equal to UT plus half AT square. B square is equal to U square plus 2AS. Okay. First I will explain the terms now. What is V? What is U? These are all velocities. Okay. U means initial velocity. V means final velocity. Initial means when the body starts to move, what is its velocity? That is U. When finishes its travel, what is its velocity? That is its final velocity. What is A? Acceleration. T is time. S is displacement. I told you this, right? So what is S? Displacement. U, initial velocity. V, final velocity. A, acceleration. T, time. So with these terms, what is the first equation of motion? V is equal to U plus AT. S is equal to UT plus half AT square. And V square is equal to U square plus 2AS. Children, these are all fixed equation of motion. First equation of motion means this alone. Second equation of motion is this alone. Third equation of motion is this. You cannot change the order. Go and learn with this order. Right? Now this one is same here. I have written here. But what is the change? Wherever you have plus, I have written minus. Why you know, children? These are the equations for positive acceleration. These are the equations for negative acceleration. That means for positive acceleration means if the body's speed or velocity is increasing. If the body is accelerated, if the speed is increasing, then these equations will come. If a body is slowing down, right? Then wherever you have A terms here, acceleration terms, as it is decreasing, no. So there and all we have to replace it with minus sign. So what are the equations of motion for a decelerating body? Negative acceleration body. V is equal to U minus AT. S is equal to UT minus half AT square. V square is equal to U square minus 2AS. Okay, now a third set of equation. Here I have replaced the A terms with G. Right? How now? What I have said here? Acceleration due to gravity. The normal acceleration, either like this or this. This is normal acceleration. When a body moves like this with the increasing speed, positive acceleration. When a body moves like this or this direction or this direction, the negative speed, decreasing speed, then this sets of equation. But if the body moves due to the effect of gravitational force, that means what? When a body is thrown up, it is moving under the influence of gravity, but against gravity. But when a body is coming down, right, it is moving towards the gravity. Right? Towards the gravity, when a body is falling down means its speed will increase. So, when a body, this is the first set of equation which will count for that. For a falling body, right? So, it is positive acceleration due to gravity. It is falling towards the earth. So, positive towards the gravitational force. So, these three sets of equations will change like this. Wherever you have A here, replace it with G. Now read out the equation for a freely falling body. V is equal to U plus GT. Yes, second equation of motion. S is equal to UT plus half GT square. V square is equal to U square plus 2GS. Now same equations for a body moving against the gravity. Satellites are launched. Satellites in a rocket only it will be kept and it will be launched. No, it will move against the gravitational force. Earth will attract like this, but the rockets need to move against the gravitational force. That time, what are the equations we need to use? So it is going against means G has to be plus. Wherever we have plus, replace it with minus. Now, send me the equation for a body which is moving against gravity. V is equal to U minus dt. S is equal to ut minus half gt square, and v square is equal to 2gs. Now all these equations are important. Write for so many times till it get recorded in your brain. Then read it, practice it well so that we can meet in the next class. Thank you, children.